Let's review some implicit differentiation, which means differentiating both x and y with respect to x in these two examples. So we want to find dy dx given x squared plus y cubed minus 4y equals 6x minus 10. So we're going to take a regular derivative of both sides, but if we take the derivative of a y term, we'll put a dy dx next to it. So the derivative of x squared is still just going to be 2x. We did not take the derivative of y, so it will not get a dy dx. Whereas the derivative of y cubed is going to be 3y squared, and that needs a dy dx with it because we took the derivative of y with respect to x. Derivative of negative 4y is going to be negative 4 dy dx equals, on the right hand side, derivative of 6x is just 6, and derivative of negative 10 is 0. So no dy dx on the right side because no derivative of a y term. Now we're going to try to find dy dx by getting it by itself. So I'm going to keep the dy dx on the left and move anything without a dy dx to the right, which means I need to subtract this 2x over. That way only the left side has dy dx on it. So I get 3y squared dy dx minus 4 dy dx equals 6 minus 2x. Keeping all the dy dx on one side and anything without it to the other. That way, to get it by itself, we can factor out dy dx. So we want to think about what is dy dx multiplied by in the first term? Well, it was 3y squared, and in the second term, it was a minus 4 out front of the dy dx. Equals 6 minus 2x. Now we have dy dx times 3y squared minus 4, so to get dy dx by itself, we're going to get rid of that multiplication by doing some division. We'll divide both sides by 3y squared minus 4. That way on the left side that cancels. We have dy dx equals 6 minus 2x over 3y squared minus 4. We can do that same thing again in another example below here. This next one's harder because we have x to the 5th times y to the 8th. So doing the same implicit differentiation, but we have a product rule here. So we want to remember how to do a product rule. So just some review of that off to the side here. If you have a product rule, you do the derivative of the first, original second, plus derivative of the second times the original first. So we're going to do that here with these x to the 5th and y to the 8th terms. Want to keep in mind, again, only put a dy dx if you take the derivative of a y term. So looking at the derivative of the first factor, derivative of x to the 5th is just simply 5x to the 4th. Does not get a dy dx because we took the derivative of only x to the 5th. So there's the derivative of the first factor that gets multiplied with the original second factor, y to the 8th. So we did derivative of the first, original second. Next part of product rule is the plus. Now we're going to do the derivative of the second factor. Derivative of y to the 8th is 8y to the 7th. We took the derivative of y term, so it's going to need a dy dx. Before I write it, I'm just going to put the original first factor in here. Derivative of the second factor is 8y to the 7th dy dx times the original first is x to the 5th. And the order of multiplication doesn't matter, right? 2 times 3 is the same thing as 3 times 2. But I personally like to keep the dy dx's all the way to the right on a term. It's the same thing as like writing 5x compared to x5. Normally, the variable we solve for, in this case, the derivative we solve for, we're used to seeing on that right side. So let's double check that product rule. We definitely did the derivative of the first. X to the 5th is 5x to the 4th times the original second is y to the 8th. Then we did the plus symbol. We did the derivative of the second factor, 8y to the 7th dy dx times the original first, x to the 5th. Next piece, we want the derivative of 9y squared. 9 times 2 is going to give us 18y, and we took the derivative of y with respect to x. Next piece, we have the derivative of 1y is 1, dy dx, equals the derivative of the right-hand side, derivative of 1x is 1. Derivative of 11 is 0. It's a constant. So there's our derivative. Now we're going to try to get dy dx by itself. I'm again going to keep it on that left side so that I can keep these 1, 2, 3 terms with the dy dx over on the left, which means I just have to move that first term. You can solve to the right. In this one, it would just take a little bit more moving than solving to the left, which is why I chose to solve to the left again. So we get 8y to the 7th, x to the 5th, dy dx, plus 18y dy dx, plus 1 dy dx, equals 1 minus 5x to the 4th, y to the 8th. Now that we have all the dy dx on one side by themselves, we're going to factor out dy dx and just say what number it was multiplied with. So for the first piece, it was multiplied with 8y to the 7th, x to the 5th. Second piece had a positive 18y, and the last piece had a plus 1. So no like terms to combine or anything like that. We're going to leave it just as is in that factored form. And then lastly, to get dy dx by itself, we would need to get rid of that multiplication and divide both sides by the 8y to the 7th, x to the 5th, plus 18y plus 1 on both sides. That way we get dy dx by itself. The derivative of y with respect to x is 1 minus 5x to the 4th, y to the 8th, over 8y to the 7th, x to the 5th, plus 18y plus 1. Kind of a crazy long derivative, but we just took the derivative of y with respect to x. By taking a regular derivative, you put a dy dx next to each derivative of y term. Move the dy dx either all to the left or to the right, and then you factor to divide both sides and get dy dx all by itself, whether it has something more complicated like that product rule we dealt with, or if it's a simpler function to begin with. You do the same rules. Regular derivative, then get dy dx by itself.